All right. Hello, everyone. Welcome to our first thematic session, which is about multimodal social sciencing. And the organizers for this session is Bernd Resch, Shaily, Gandhi, and David Hanny. They are all from the ITU, University of Salzburg. Welcome, and feel free to post questions in our channel or comment in the channel. And Bernd, I see you and your organizers are all in the local hub. I will pass the stage to you. Thanks.
Good, thanks so much, Ray. So thanks for coming, everybody. The idea today is that we talk about multimodal social sensing. Why multimodal? We talk about multivariate lots of times when we are in the GIS domain, but then multimodal is just a bit of a different thing, right? So I just want to introduce my two co-organizers, David and Shaily. Do you want to say a few words?
Hi, I'm David. I'm a researcher in more or less spatially explicit machine learning with multimodal data.
Hi, I'm Shaily, and I'm postdoc at Geospatial AI Research Group at ITU.
Good, thank you. So let me see what we're gonna do today with you guys. One of the first part is the intro, basically, and setting the scene. That's what we basically do right now. No? So it's like just, I don't know, maximum 10 minutes to say we just try to get a bit into the topic. Afterwards, we're gonna present, I don't know, let's see, 3 best practices, if you wish, so to say. So just 3 examples of how we think multimodal analysis can improve our understanding of geospatial and social processes. And then we're going to go into an interactive session. I'm going to say a few more words in a second, which lasts like, I don't know, 30 minutes or so. We're going to collect your inputs and discuss that as well. Very quick wrap up in the end, of course. Good. So what's our way of thinking? The idea would be if we use multiple modalities, we get more or higher quality information. So that sounds like a lot of information fusion, but then again, it's more like understanding and using different types of data. So it's not different variables, but it's different types of data, which could be imagery, which could be text, which could be, of course, the geospatial and temporal components of the data set. And multimodal analysis, in our understanding, is not, again, explaining one variable with a number of others, like we often do, like, I don't know, perception of green space with a number of others, but it's more like merging, so to say, several modalities into one combined representation. Call them embeddings or call them like the output of a machine learning model. The idea, the general idea is to really feed various encoded features, embeddings again, into a machine learning model, and from that, like, learn a bit more about the actual phenomenon under investigation. Good. So what we're going to do today, this is just the call for you guys up front already. We would like to know from you, and that's the theme of the session, which modalities are you using currently? And secondly, in which data sources are you using them? And there is going to be a bit of an extension there as well, like what are you using it for? Application domains or problem areas and so on. And furthermore, which methods are you actually using? And what do you think how we can like benefit from that as a discipline? Good. So the point being here, which modalities and from which data sources are you using? Please feel free to put this into the comment section of the AirMeet system already right now, like on the go. So we're just going to keep collecting this in a Miro board throughout the next, like, I don't know, 20, 30 minutes when we present our lightning talks. And then afterwards, we're going to discuss this together with you guys. Good. So we're going to start with the 3 lightning inputs. David.
Good. So the point of the lightning inputs is to give you some examples on how we utilize multimodal machine learning to gain a holistic view of what is going on in geographical space. In this case, we're talking about disaster management. Disaster management because a view of information from multiple perspectives can be very crucial to actually understand what is going on. In our case, we derive information from georeferenced social media data. Geosocial media which is in this case actually the only source of information, but still comes with several aspects and modalities, and also dimensions that need to be considered. On the right side of the screen, you see an example of a tweet regarding the 2021 Arweiler in Germany. We can see that, well, there's some text, the person describes what is going on, there's some emotion and sentiment, but since it's georeferenced social media, we also have a location and a timestamp. If we have many of these posts, we can, on the one hand, increase situational awareness for emergency response entities by providing a common operating picture. On the other hand, it is possible to extract actionable information from some of these posts that would actually benefit the planning of further efforts. Looking at the posts a bit deeper, we can derive somewhat of a hierarchy of modalities and dimensions. We obviously have the text, and the text contains the what or the semantics. But it also, as seen in the previous tweet, it contains sentiment, be it positive, negative, or neutral, or emotion, which is even more fine-grained with fear, joy, anger, and so on. We then have a location in the form of a point coordinate or a polygon geometry representation, and we have a timestamp. And these aspects alone already provide the possibility to gain a very holistic view of what is going on social media to better understand the social responses to a natural disaster or also a man-made disaster. Typically, these modalities and dimensions are fused using independent processing steps. So we take each of these dimensions that we see here and we process them independently. We extract semantics using some kind of classification or topic modeling model. We use a sentiment classification model to maybe extract sentiments, and then on top, spatial analysis or temporal analysis. However, with these independent processing steps, we, on the one hand, disregard the interconnections between these dimensions. So maybe there's some topic and it has a sentiment or emotional association, which is not reflected in your analysis. And also, depending on how you order your processing steps, you will get completely different results, which is, well, depending on what you want to get out of it, can be good or can be not so good for actually gaining a full view of what you want from the data. So can we do better? Can we do a more integrated analysis that is not dependent on independent processing steps? One way to do this would be to create a joint representation of the data. In this case, we took, this is an example of one of the approaches we used in one of our studies. We took the documents. So the documents are independent posts with coordinates, text, and timestamps. And we fused all of the information present in the documents into one joint feature vector representation. This is mainly the vector that you can see here. It consists of numeric dimensions that represent coordinates, semantics in the sense of semantic embeddings, sentiment, classification, probabilities, or some other kind of numeric sentiment representation, and a timestamp. And I will go into that in a bit more detail here to better understand or to better represent it. What you can imagine comes from the feature vector is that the feature vectors in, sorry, wrong direction. The feature vectors basically span up a multimodal space. And the point is that similar, sorry, the buttons are confusing. The point is that documents that are similar across multiple modalities are similar in terms of the vector representations. So what you would get is that if posts are about the same topic, they are of the same sentiment, posted about the same time and in the same region, then they're very close in this multimodal space. And if they're not similar in some or all of these dimensions, they're very far apart. We produced these embeddings using multiple models that don't necessarily output a discrete result as you would have for a topic model or a classification model. But we, in the first step to create these vectors, translated everything into numbers in the end. So we used semantic embedding models like SentenceBird to represent semantics numerically, and we could also normalize that. We can use sentiment classification probabilities to have a continuous numerical representation of sentiments or emotional distributions. We can normalize and project coordinates to achieve the same thing for the spatial representation, and we can normalize time using something like Unix time and then normalization. And then you have a feature vector that represents different modalities and dimensions with the same types of numbers, more or less. And these can then be used to conduct analysis in this multimodal space. One example would be clustering, finding out what is going on where and how people feel about it, and also when. Clustering of posts is in this multimodal space on the one hand trivial, but on the other hand also not, because when you just cluster it with some basic algorithm, you will end up with a situation that posts might be similar in semantics, but very different in location, and then they're in the same cluster, but the geographical meaning of clusters is once again diminished. So we try to mitigate that by using a spatially explicit clustering algorithm, in our case, an adoption of the GeoSum, so geographic self-organizing map, which we adapted to be dynamic. So it starts with 4 neurons, grows a dynamic neuron grid based on accumulated errors. So we cover the data and also don't need a predefined number of clusters. And on the other hand, we grow a neuron grid that is spatially coherent, meaning that the learned neurons are close in geographical space, and the represented clusters behind the neurons will also be close in geographical space. This, in the background, works by hierarchical search procedures during the training, which first searches a best matching unit in geographical space and then in the rest of the modalities. This can obviously be adapted for other needs as well. To give you a better grasp on what the actual results look like, we conducted a case study regarding the 2021 R Valley floods with 11,000 tweets. And coming back to what I said earlier, what do people post about? How do they feel about it? And where do they post about it? And also when. One output that you can generate with this approach is this kind of map. It's a lot of information at first sight, but you can break it down. So first of all, we have convex hulls of clusters that represent collections of posts. So these convex hulls are more or less the regions where one coherent collections of posts are. And we have a label that is associated with it, generated by an LLM here to automate the whole process, representing the semantics. And we have a semantic sentiment association represented by the color. So, and this is the result from 11,000 posts. We can boil down a lot of posts quite quickly in multiple modalities and dimensions quite quickly. We can obviously visualize that in multiple ways. We can do a temporal map depicting how these clusters evolve over time. The flood was about July 14th to 15th, 2021, and you can see a spark of negative clusters after that. And you can also look into the clusters if you're interested in, let's say, cluster 76, which is very disaster related. And there we have actual reports about what people experienced during the event that can be used by emergency response entities to go into depth even more. The question with this is always, however, how do you evaluate something like that? Because we deal with so many modalities and dimensions that have been used in the past somehow, this approach is still not really comparable to the past approaches. What we tried and what we are still trying to is to compare these types of integrated analysis to what is done before, namely sequential workflows of independent processing steps. it's obviously not possible to exactly reproduce what we did here with independent steps, because, well, that's the drawback of them. But we can compare the outputs of a similar approach to our approach. What we found, for instance, was that if you do just topic modeling and sentiment classification with further spatial analysis, is that with our integrated approach, we were able to produce much better semantic topics because we don't have a workflow of topic modeling and spatial clustering in a sequential workflow that results in redundant topics. We don't have that. We consider both simultaneously. The same goes for sentiment uniformity. So how uniform is the cluster in terms of sentiment? Since we don't first process topics and then sentiments and then try to merge those two, but we'd rather process them integrated, we gain a higher uniformity of sentiments in the cluster. In terms of spatial variance and temporal variance, the two approaches were quite similar. However, we can show that this integrated analysis can actually be better than just a sequential workflow, and thus potentially also be more useful in practice. What we now saw is that we just use text together with location and time. However, we can obviously easily add in images by using some kind of vision language model that has a joint representation of images and text. This is very trivial with something like Flip or Blip or similar. It is also possible to use the text or the image to feed into the other modalities like location. We can extract location from images using either something like an LLM or the metadata, but we can also use geocoding to extract location from text. And then moving on to a similar but different topic, namely multimodal contextual enrichment and information fusion from Bernd again.
Thanks a lot, David. Shaily just wrote it to the chat, right? Don't forget to put in your modalities, methods, application domains, and of course, the data sources you're using. Good, so touching a little bit upon what David said. I mean, this is what we all know, right? Where we're starting from, like these masses of data in terms of social sensing. What I want to say here is the modalities that we can draw from them are very different. Meaning there is, of course, text in there. There is sometimes videos, there is images, there is, of course, the geospatial dimension, there is a timestamp. And there are all different kinds of let's say, data types in there that may describe a phenomenon under investigation. Good, so this is what we know, right? Namely, these temporal signatures. 2 weeks of tweets in this case in California. Here in the middle, you see this very strong spike. If you zoom in a little bit, you can see that on this very specific Sunday, which is basically the blue curve, which is very similar to the orange one, which is a week before, like in the middle of the night, midnight to 6 in the morning. Not many people are posting on social media, but then a week later, all of a sudden, we have this spike like at 3:20 in the morning. And you can make a guess when the earthquake actually happens. There is a 0-minute delay, basically. Okay, this is what we know, and there is a lot of research being done on that. That's the temporal view, and that's the spatial view. Of course, as we do in our geospatial research, a GeoAI approach towards identifying the areas affected by natural disasters, in this case an earthquake, but that works for hurricanes, that works for flooding, for storms, for wildfires, all different types of disasters. And of course, these red areas here indicate hotspots, meaning that these areas have been affected by the earthquake. In blue, we see that these areas are also talking about the earthquake, but they have not been affected. And in yellow, we're just not so sure. In the end, we talk always about confidence intervals, like statistical probabilities. Now, of course, this can be ground truth with all different kinds of official information. In this case, it's just the USGS earthquake. Good. This is what we have been knowing for like 10 plus years, right? And this research is not new either. I'm just pulled it out of the box, so to say. Now, what I would think is that there are two different method families coming up that we need to take into account a little bit more. One of them is information fusion. Here is an example from disaster management. what we have here is 3 different information layers, really. So the first one is flooded areas as derived by remote sensing imagery. The second one is disaster hotspots as derived from social media analysis, as we just saw. Then the third one is population density. And if you bring them together somehow and mingle them properly, you could get into something like this, which it's called focus maps, like a very specific way of using information. Focus maps, where is the juice just happening? Where do we need to look at as disaster responders? And that's basically this integrated view, because when we talk to disaster management people, they say, yeah, it's great that you have your AI methods there and that you do your complex analysis. What I'm interested in is whether this area is red or green. Do I have to intervene or not? That's everything I want to see. And then we have a lot of discussions, because like hiding complexity is always good, but then it hides complexity. So it also reduces the information gain that we can actually get. And that's always the discussion here. So in the end, this is this red-blue map, right? Like, which areas do we have to focus our disaster response in? Good, and that's what the real-world example looks like. So building densities here, the flood masks as derived from remote sensing imagery, and the Twitter hotspots in this case. And then we merge that into a single hotspot map, and we identify, so to say, what the most affected areas are. Good, so the second, I don't know, family of algorithms, if you wish, I want to get into is called contextual enrichment. It's a little bit different from information fusion. What's the idea? Here on the left side, on the right side, sorry, we have a series of mobile phone data-based people densities in the city of Vienna for a number of days. You see as the hours progress. So we have, first of all, temporal resolution of 15 minutes. We have a spatial resolution of 50 meters that can go down to very fine-grained, actually, rasters in the simplest case as well. Good. Now, what do we see here? We see this like flickering image there, and there are things going on. But then again, it's very semantically poor, right? Because in the end, what we see is the density of people, but we have no clue why those people are there. And that's why this contextual enrichment comes in. Meaning, first of all, we want to get into, let's say, semantic analysis, as David just said, and also emotional analysis. So semantic analysis, what are people doing there? Why are they there? What are they talking about? Is it just random jibber jabber about everyday activities, or is it tourism or whatever? Or is there a specific reason, which could be a demonstration, which could be a traffic incident, which could be a large urban event, for example? And the second part is the emotional part. So how do people feel? Is the situation easy and everything is just celebrating Vienna Pride? Or is the thing like very dense already and it's close to escalating? So just to get a glimpse into the situation and to get an idea of what's happening. And that could be one of the outputs. And that's obviously not the most elegant one, but it's 2 different time steps telling very different stories. Remember this again, we just see these flickers, which we can't really gain much from. Whereas this, here we see that first of all, we have this cluster of people, however we detected this cluster, but detecting crowds, like homogeneous crowds, is still a separate like research topic. So we detected these clusters, and these clusters have different qualities. They talk about different things, they have different emotions. So this, by the way, is from the Vienna Pride Parade. That's why people talk about spirituality, queerness, social issues, and so on. Is neutral to negative, so there is something heating up, but it's pretty large crowd with like 19,764 people in there. And that's real data, right? This is not fictitious. Over there, again, people talk about Vienna Pride. It's neutral to positive, everybody's relaxed. And it's like 5,989 people here and 3,600 up there. So we have a bit of a feeling in like very, let's say, spatially and temporally fine-grained resolutions, where people are, what they're doing there, and how they feel. Good. So this is the idea, just to integrate different modalities and then try to gain a bit more insights into different, in this case, urban processes. And with this, I would like to hand over to Martin Moser, who's going to talk a bit more about the understanding of human perception through social sensing. Martin, are you there?
I'm here. Hi, everyone, and thanks for the opportunity to present my research here on the stage. So basically, going from this joint representation of multimodal data that we saw in David's work to arrive at like a common embedding space, we would take a more coordinated representation of multimodal data. So in this line of research, we're actually using wearable sensor data to collect multimodal information and understand human perception of space and the immediate environment that is affecting it. As you can see on the slide, we kind of came up throughout the last projects with a data collection methodology, which integrates different modalities of data. So we can see a chest strap recording cardiovascular data of a person. We have like a wristband that collects different physiological reactions such as skin conductivity, skin temperature. And then we also have like GoPro camera footage, which basically gives us this first-person view of what a person actually experiences in a particular context. And then we have like an eDiary app as like the interface that kind of connects the different data sources and adds a spatial reference to the sensor measurements that we record. We can see in the second step that we actually have like on one hand like this time series data source of physiological reactions, which we can analyze through signal processing techniques. We can build algorithms to detect stress or negative emotions from this. We can spatially aggregate these negative emotional situations to identify areas which could potentially be addressed by urban planning in the context of, for example, active mobility for cyclists to feel safer or for pedestrians. And then we also collect like subjective qualitative information through either like post hoc or in situ interviews or post hoc questionnaires to actually add another like modality to our data set, which is the information through like feedback of or textual feedback of a person. And the last step, we have this video data where we actually have another source or modality of data that we integrate in our workflow. We can move to the next slide. So as you can see, like we have different perceptions of space, and the reactions or the physiological reactions of people are different depending on the context and their experiences. We can see like on the top left a scene where a cyclist might be stressed because of like close overtaking, so a very narrow road. But people like usually associate, for example, green space with more relaxation. So we tried to actually like use different modalities to better understand how people actually feel at particular situations. And as you can see on like this slide, we have like, for example, an area of green space that is actually like, or people would think would be associated with positive feelings, that actually turned out to be like very stressful for cyclists because of the narrow road or like close passing of cars. So basically, we tried to collect different modalities to understand how people feel and then relate this to the immediate environment. If we go to the next slide, we can actually see that we collected lots of different data sources and basically movement trajectories for a city. In this case, it's the city of Osnabrück in Germany. And we try to use that data to understand how people felt. So if I go into the different data sources that we collected, it's basically movement trajectories. We have time series data in form of physiological reactions. Based on this, we can derive like negative emotional states or stress situations. And we also have this ego perspective camera footage, which adds another dimension. And based on this, we try to actually relate this to the urban environment. And we do this by actually map matching the physiological reactions and the trajectories onto the underlying road network by using map matching. And then we add additional like features to our data based on OpenStreetMap, Overture, mapillary, which would be describing the built environment. And then we can also use, for example, satellite imagery, also street view imagery and video data to actually describe the natural environment that a person perceives. So we try to integrate all these different data sources and add as much context as possible to understand like how a person felt and what might have caused this feeling. And for this, we can also use different kinds of data representations. If we move on to the next slide, I already said that we're using, or we can use, street view imagery. The problem with that is the temporal reference, or when that particular street view image was recorded, might not be the same, or like might not be describing what a person actually saw. So what we can do is we can create our own dynamic street view images through like the eager perspective camera footage that we recorded. And we have like a spatial and a temporal reference to these urban perceptions of the natural environment. And that's what we have integrated in our last, or like in our recent research. We used for once the GoPro video footage that we recorded. And then we also have eye tracking data, which we can also use to segment the natural environment that a person perceived. And the last slide that I have here would be kind of already going into this discussion that will hopefully bring in some interesting ideas. So if we have this multimodal representation of different like data sources, how do we best combine them? Like for once, we can actually like translate between different modalities of data, which we saw very recently with which LLMs have been capable of. But then we can also think about how we best present or represent the data coming from different sources and modalities to kind of have this like common view or like a common representation that we can use for further learning, which kind of brings me to the questions I added at the end, which hopefully will stimulate a fruitful discussion here.
All good? Thank you. So now there are a few things that we should probably quickly revisit and discuss before we go into the discussion. So first of all, there were a few questions from the audience as well. And second, there was the request to reiterate on what's to be done with the chat, so to say. So what we try to do with these like 3 quick lightning talks is not to present our research too much, but just to say, this is what we think multimodal research could look like, and just to give you a little bit of food for thought for the ideation and the subsequent discussion right now. Now, if you work with any kind of multimodal data sets, data sources, if you work with modalities that are not only spatial analysis, like, I don't know, spatial clustering, just like you saw right now, then please feel free to share your data sources, your modalities, your experiences, your methods, all different kinds of things in the chat as well. Okay, good. And then I would quickly go into the chat and go one by one. I would not discuss the details of our research methods here because that's not really the goal of the workshop. But just to say, for Zheng, for example, so just a very quick superficial answer here. Like the question was how exactly we overlay those information layers and which methodologies we use. The idea is this: we start from the assumption that if the flooded areas as derived from remote sensing imagery and the disaster hotspots from social media overlap, there is a very high probability that there is really disaster happening there and urgency is given. And there is always these two ways. You can always say where it overlaps, there is a very high probability, but the other way around would be you can always fill gaps one with another data source, right? So for example, we know that the remote sensing technologies oftentimes don't work very well, I don't know, in densely built up areas, but that's oftentimes where disasters happen as well. Or they don't work well when there is cloud cover. So then social media, for example, can jump in and fill the gaps that the remote sensing leaves. And the other way around, of course, where nobody posts in social media, we cannot calculate social media hotspots. But then again, over large areas, remote sensing is a very good environment. So this would be my answer, saying if you would drop me a line by email, then I can send you the according paper as well for more methodological details. Good. The second question, oh, there is also an already on stage on the screen. Thank you very much, Simon, for checking back with us. So I'm just reading it out quickly. What is the advantage of using a multimodal embedding when you could just use simultaneously, not sequentially, all of the temporal, spatial dimensions in a single vector space without embedding and do some clustering on the data? So, I mean, perhaps we can have a combined answer here. My quick one would be, I mean, the embeddings are still somewhat specific to the modality because there are like very strong assumptions on how we generate embeddings for each of the modalities. No, so in my point of view, generating modalities one by one and then merging them, so to say, in whatever fusion process. David presented this self-organizing map there, the GGSOM, would be an approach where we really like feed different modalities that are somewhat independent from each other, but are then combined into a common representation and then describing a specific spatial or social phenomena. Perhaps you want to add there?
Yeah, maybe quickly adding on that. If I understand the question correctly, we're talking about very similar things here. For us, as Bernd also mentioned, one challenge was particularly the different embeddings or the vector value range these different modalities generated. We have something like semantic embeddings, which have usually a very small value range, while projected coordinates are huge in their value ranges. And if we cluster in a vector space that is just these this information in one big vector, then the clustering is very skewed. So if that's what you're meaning, our idea was just to have a normalized representation with where each modality basically adds in the same amount of distance in terms of what you want to represent.
So Simon, I would mostly agree with David. I don't know whether you would agree with us. Of course, if you still have a follow-up question or contribution here, Ivan, we would be happy to move Simon on stage as well. Or Simon, you can always ask a question or follow-up question as well in the chat as you wish. Yeah. But happy to discuss that, obviously. Because this is, I think, exactly the type of questions we need. And we know that you're very strong from a methodological side as well. So this would be a very valuable input. Good. So before that happens, I would just go through the next question from Shaily about. Oh no, there is Simon. Hi, Simon. Do you hear us?
Hi, guys.
Hey. Thanks for joining.
Hi. I hope you can hear me. Or
yes, we can.
Okay, great. Yes, yeah. Basically, I think that is the point you're making is that this embedding normalizes these dimensions, right? That's the issue, right? So the whole thing is not about combining these dimensions, because you can combine them also in different ways. And actually, you need to not only combine them, you also need to distinguish them. For example, in order to distinguish causes, social causes from effects, right? So just integrating them into a single dimension doesn't do the job, right? You need to basically still be able to distinguish them. But I guess I agree that the advantage here is that you basically can use that that methodology to normalize the different dimensions. So if I understand it correctly, right? That's your
Yes, exactly. And through, I mean, we went a step further, and with after normalization, you can always add in different weighting schemes if you want to emphasize certain dimensions more or less. But yeah, that was the point.
Yeah, but then sorry, just to add one question to that one, because these normalizations, right? They are normally purpose dependent. So you basically, the way you normalize, for example, space depends on your purpose, right? Whether that's actually useful or not. So I was wondering, actually, don't you have to, basically, can you really find one way, one single way of normalizing space for all purposes? I'm actually doubting that. Sorry,
No,
just
not at all. So this would be have been the way to answer your question as well. Now, namely, this is always the issue with investigating multimodal phenomena, right? So let's say spatiotemporal analysis, like a spatiotemporal, I don't know, Gettysburg GI star or whatever it is, hotspot analysis. It has been there for like, I don't know, 7-8 years in ArcGIS, and you can just run the tool and that's it. It's not the technical issue. It's not the issue of the formula, but it's an issue of how you normalize and how you choose the weights matrix, right? And the problem there is, if you have a geographic space, you have two axes with the same unit, which could be meters, which could be degrees. And then on the z-axis, what you add is seconds or hours. So if you want to analyze, not let's say raster cells, but voxels, you need to define what a voxel actually is. And we always need to take our assumptions, of course, from the specific application case.
yes.
So you want to work backwards, obviously, right? You want to, if you, I don't know, have a spread of contagious disease, it makes a difference whether it's a vector-borne disease where mosquitoes fly around and bite you, or whether it's a transmissible disease which happens by aerosols from human to human, right? And modeling and understanding this process is absolutely crucial to design the features, and normalizing the data from 0 to 1 just with the min-max normalization doesn't make sense at all, obviously. So I totally agree with you there.
Okay, yeah. Thanks a lot.
And that's a bit of the holy grail, you know. Have you got a formal approach how to define the weights matrix? Let me know, and be happy to follow along. Good. So there was this other question from Shiloh as well about biases and the functionality of the sentiment/emotion analysis. So I mean, I could talk in an hour about this right now. I'm going to be very brief. First of all, the first challenge that we're getting into is, and you witnessed that, we did not talk about sentiment analysis, but emotion analysis. So sentiment analysis has been there for ages, and if you take a look at papers out there, most of them talk about sentiment analysis. We talk about polarities, exactly. We talk about polarities from positive to negative, somewhat neutral, and then you can define classes and so on. This doesn't give us much. It doesn't cast a very strong understanding, let's say, of the process. So that's why we've always been going towards emotions, like for the last, I don't know, 12 years or so. And there are, again, a dozen of different emotion models, which could be cylindric, which could be like totally independent emotions and so on. Obviously, it's very hard to analyze and categorize emotions. And now the next step we're taking, and that's a big one, is aspect-based emotion analysis. So defining an emotion or a sentiment for an entire corpus or document, which could be a social media post for us, is somewhat easy or a somewhat solved problem. But now what we want to know is which aspect terms, I mean, which words in the simplest case, which expressions an emotion refers to. And that's the important part for also disaster managers and others, urban planners, to be able to interpret the emotion and let's say derive actions from that, right? And that's something that is just a hard problem at the moment. I mean, we know that human language is very redundant, it's very inexact, and that puts us into a lot of troubles. So the gold standard that we're pushing right now is in the confusion matrix, a precision of 0.58. And that doesn't sound like much, but it's actually not so bad. Good. And so biases, yes, of course. I mean, how do you ever annotate a labeled data set? Not an easy one. So we have been switching from, let's say, microtasking, just putting lots of posts to people, towards consensus-based labeling. So in groups of like, I don't know, 3 people, we really talk about what we think and what we observe. And then we find a majority vote for each label, which gives a totally different connotation, obviously. And it has all pros and cons, but at least we have a more homogeneous data set as well. So this would be the first answer to that. But if you're interested on that, Shadow, then always more than happy to follow up, because that's a problem that is driving us heavily as well. Was there a 4th question, right?
Is one last one.
Oh, yeah. I mean, the spatial resolution problem. Thank you. That's a standard, a big one in spatial analysis, right? So I think I would not take that in right now in this very workshop. I mean, aggregation, disaggregation, we know all different kinds of problems. We know about the modifiable areal unit problem and so on. So I wouldn't really take this on here, because this could be a separate workshop, I guess. But yes, very much of an issue that we're facing, especially in the information fusion part that I showed before, with the sort of media hotspots versus the flooded areas from satellite imagery or drone imagery. Good. So is there any more comments or inputs from the Q&A section or from the comments section? Because then I would say we can just look over to the Miro board quickly. If I find it.
It's there. Lost.
So,
Oh, yeah.
good. So thanks a lot for your input so far. We've been collecting a few of those, and perhaps we can discuss those. But before we do so, I would just hand the word to you guys. So, which is the people in the room, physically in Vienna, obviously, but also everybody else online. Because we've been talking a lot already, so I'm happy to hear experiences, obviously.
Can the people online just speak, or do we need to?
So we can always put people online to the stage. Ivan would be happy to do that. Thanks for supporting here. Or you can just put a comment in the comment section as well.
I can start.
Yes, Vanya.
Assuming
Can
that
you-
I can see it, but I cannot
Can you
say.
quickly introduce yourself to the online audience?
Yes. Okay. So hello everyone. My name is Rania Kunadi, and I'm an assistant professor here at the University Analytics Department. So, I will just see where in these categories. So I will just say what I do, maybe different, or where I see something similar. Right? I think this is the point of discussion, or at least to start the discussion, yeah? And then we can all talk, and then we see where this goes. In terms of data sources, for example, what I see that you have here, we also use social media posts, for example, from Foursquare, and what else? I don't know if you have open source data in general from OpenStreetMap, but the application that would be the application areas is an application that I don't see here. So we use social media data in the context of inference attacks for location privacy. So that I don't see this application there.
I'm here in a second.
Yeah.
Right?
Because I didn't write it, so I'm sorry. And I'm sure there will be correlation to that degree regarding the methods that we use for this data and for this application will be massive attacks using machine learning techniques. Classification, because they are semantic inference attacks.
Would it be can you be a bit more specific there? Like either a family of methods or even
in
specific
this particular study that I'm referring to, I think X gradient boost was used, but it could be any machine learning algorithm that could be used for classification of the semantic type of attack. For example, identifying the type of location of the user, or the user's profile of locations, types of locations. Yeah.
So what would be the multimodality in there?
That's the problem. I don't see. The only methodology, well, it could be in terms of the modes of analysis, that one side is the machine learning and the other side is the spatial analytical one, because they were combined and separate approaches to do an inference attack on the location profile or the user profile. So if, I don't know.
And this is mostly, let's say, trying to infer personal data from the location, no?
Yes, yeah.
And
User
location data, I
profiles.
mean, we've been a lot through location data, and I mean, is it Foursquare you're working with most at the moment?
For this study that I'm trying to connect, which might not connect, so maybe it's a bad example, right? There's also another one. For this study, it was Foursquare data used as the training data, along with POI data from OSM, to train a model that could potentially, and it could actually, not potentially, that does predict the type of location, the type of visit of a user, but also the user profile overall, where in the scenario where you will have only a set of locations. Yes, but these were the train use data in this scenario. Yeah, I don't know if it connects. It's not so really multimodal, but
I mean, in the end, like user profiling is very much multimodal, right? I mean, location inference, or let's say individual privacy or re-identification, so to say, from location data is a very specific thing. But then again, user profiling, meaning identifying a person using a variety of variables, which could be location, but there is a number more, obviously, including credit card transactions, so on, right? And there was this paper one from de Montoya et al. In 2013 already, and they said like, if you give me 4 random positions from your daily mobile phone records, I can identify you with a probability of 92 to 93%. And that's 4 positions random. And so we know that the location is a very strong proxy for identity.
to add here, because very frequent, this paper has been misinterpreted to uniquely identify, not re-identify the person, but to single out the person, because
Absolutely.
people think something else.
Good point. Thank you for clarifying that.
Okay, I'm in the start, so please move on. But I can also say what they do.
Application. So finally, there is coming something from the internet. So application accessibility for disability, very interesting. Data sources, aerial imagery, LiDAR, open data transportation network. And the methods would be random forest and point CNN. Charlotte, do you wanna come to the stage? I'm not forcing anybody, obviously, but this would be really nice to elaborate on a little bit more, especially the point CNN part, I guess, the methodological part here. If that's okay with you, Ivan can move you on stage. Or Mina can, perhaps you can. Ah, okay. Perfect, so we're waiting for a second.
Let's try.
Hey, Shiloh. You hear us?
Hear me or see me?
Yes, we can hear you. Thanks for joining us on stage as well.
It's facing. Oh, I will just turn the video off. You don't know how to make it to the right place. So yeah.
No worries, you can always talk and we can hear you.
Okay, you can hear me. I've done these methods to try to identify programs in particular. And I thought that the point CNN methods would be effective, but they were not as effective as random forest, as simpler models. I think because of the quality of the LiDAR data. So I think that's an area that could be more effective in the future.
So why would the point CNN not really work? Is it the question of the data, or is it a question of the suitability of the method here?
I mean, it could be either. The point CNN should be more spatially aware than like a random forest or a non-geographic machine learning method, but a curb ramp is so small, like usually 3 feet by 3 feet or 1 meter by 1 meter approximately in space, and the LiDAR point clouds were maybe not dense enough to be useful for that. But at the same time, maybe aerial imagery is a better source because of the sort of visual characteristics of the program.
Very interesting, but I mean, what my problem with random forest is always this like kind of hierarchical way of thinking, right? So does random forest really cover the phenomenon, I mean, the disability accessibility that you want to investigate? I mean, it's a very strong simplification, random forest, no? As compared to, for example, a CNN.
Yes. I would maybe argue, which maybe in this group is less agreed with. I like the random forest in that I can know what the model is doing, whereas the point CNN is so opaque and complex that you don't exactly know where it's going wrong or how it's learning. And I think in this case for curb ramps, I had information about distance from street intersection, kind of basic information that I believed, I will present sort of on this tomorrow, but I believed that the model was perhaps identifying something other than curb ramps, but narrowing the space to then identify the feature maybe manually or ground truthing.
Okay. Yeah, because I mean, random forest in a way is a somewhat sequential thing, right? Like you define the most important features and you go down a tree, so to say, no? Or a path in the tree. Isn't that a bit disregarding the co-occurrences of things? Because in the end, you say that's the most important feature and the second most important, and then you go through and then it adds up to a, I don't know, predictive quality of 87.3% or whatever, no? But then again, isn't that under representing the complexity of the phenomenon in this case? Like, I don't know, having the combination of an intersection and a pavement and I don't know, whatever it can be, green space and so on?
I think perhaps, yes. I think I would wonder if the complexity, if any model could capture the complexity of the real world fully.
Yes. Oh, that's good.
So yes, I mean, I think you're correct, but I wonder, even with the point CNN, I think it's missing, even with better data, that it would be not capturing some complexity, but it would be harder to see what that complexity was.
Okay, thank you.
Mm-hmm.
Thanks so much for joining us as well. So happy to follow up by email as well, right? If there is a further discussion to be held, more than happy. Good. Is there anything else from the audience, either on site or online? Data sources, methods, perhaps even. We haven't talked so much about those yet. Data sources are a bit clearer, I guess. Oh, there is another question from Roar. Thank you very much for joining us. I'm just going to read it out quickly. I've been working on combining spatial, extent, and metadata descriptions for geospatial data sources to create a knowledge graph of domain data sets. Then further downstream, tasks I'm interested in is natural language search into this knowledge graph. Oh, do you want to come on stage as well? Because this sounds like, oh no! There's no side.
Yeah.
Sorry, I didn't realize. I don't have to scream so much.
Yes, so this one, I'm a PhD student from Copenhagen, Denmark, and this is kind of what I'm working on right now. So we have this, so I'm coming at this from fair access to data and making access to information equal across different user groups. Maybe this is kind of an angle to this. So when you, as a user, create a query to search a collection of data, how specific do you need to know all the terms of this corpus of data sets to find relevant information? And to kind of lower this bar, you can say, okay, it's how can we use natural language to then lower this bar. And that means for this knowledge graph I'm looking at creating is maybe using kind of like in iterations, create the ontology from, you have all the metadata descriptions of the data sets, and then you can use named entity recognition to like kind of get the keywords out of this maybe, and then to, there's even similarity researches between the query and the data sets descriptions and so on. But at one point, so then when we have that from this formal metadata description, how well does that work with how actual people actually query the data? Like, do these match in terms of the terms being used in metadata description and the user queries? And then maybe aligning this somehow is what I'm looking at.
And you guys have the answer for now already, know how well it works. So which metadata fields are you looking for them? Because there are the very structured ones which have predefined data types. I don't know, they're easy to fill, but they need to be filled. So that's the next question, right? And then there are the more verbose ones, like a verbal description of what it is, what it does, and so on, right? Is that a combination you're thinking about, like doing like everything at once?
Yes, that's what I've been thinking so far. But the corpus of data I have, this is for marine and freshwater like data, pollution data, fish species data, and all this kind of different information. But a lot of them don't have very well filled out with data descriptions, of course. But then, thinking of ways to kind of combine this into and representing each data source in a knowledge graph to maybe do some kind of similarity searches between the incoming user query and the graph structure, basically.
That sounds like an extremely cool challenge, because you have this, again, very strongly formalized, so to say, metadata, and then the more human readable ones. And then, I mean, how I would imagine it, like if we would be very blunt, is we could say we have the knowledge graph with all the information in there, we put an Elasticsearch on there, and then that would do the first trick already, perhaps not perfectly well. The second one would be, I mean, I hope you're going to be here for tomorrow's keynote as well. I would say, why not feed the data to a, whatever it is, large multimodal model, large language model, and then run the search there, no? It can figure out itself what's important and what not, because then we don't have to train random forests, point CNNs, or whatever. It's just like use what's there, because spatial question answering with LLMs, I think, is not working so badly at all at the moment. Do you think this would be a viable approach, or is it just like, because I mean, it renders our research relevant to some degree as well.
Yeah, for sure. But I think so. The specific thing I'm working with is getting, like, this is a list of a corpus of data sets, but then we should get users to find specific things in that data set. So the general models that exist, is that what you mean? Like they don't really consider these specific data sets, I guess, because like spatial question answering, it's not included those, I would say. But I don't know. Yeah, so I'm looking forward to hearing tomorrow.
So what? No, I'm not answering your questions there. I can't, obviously. But what would be a question you would like to answer? Like, what would be a search term? Like you talked about fish populations, right?
Yeah. So the idea is, so for example, you should not think like, where are pollution sources and fish species in this river, for example. And then the data sets, like kind of answering that query should pop up, and then you can go further with it. Like this is kind of maybe an initial process in a workflow, a research workflow. So it's finding the relevant information to this query. So not answering like specific questions, but I think that's the.
I mean, this could be like a very generic approach, obviously, right? I could always transfer your use case to industry and say predictive maintenance, for example, which machinery has which metadata, and perhaps even we could talk about sensor data somewhere here as well, no? Like which statuses do we observe at the moment, which measurement data, and then how does it influence the production process if this thing breaks, and trying to monitor the entire system. could actually be a similar idea to use knowledge graphs to model the entire process. And then some of them would be more formalized and some of them would be more soft, so to say, but then more comprehensive and expressive as well, no? And then combining those sounds like a very neat challenge there. How far are you in your PhD?
You know.
Okay, so there's still some time left. Let me know a year or two. I don't know whether somebody wants to touch upon that directly or any other aspect.
So I think there was a comment by Jano about, we discussed a bit about joint representation learning and coordinated learning in the chat first, and then also this comment came up.
Is there a conclusion from the discussion already, or was it just a number of statements?
More of experiences, so to say.
Okay. Sorry, Ivan, can you, or Mina, can you quickly move the comment again? I could read quickly enough. So Jano said, the benefit of a knowledge graph approach is that you get both declarative reasoning and inference versus representation learning for a dataset search. Exactly. So that's feeding back to all, right? And that's the understanding right now. By the way, we tried purely NLP for dataset search several times with industry players, and the results were mixed at best. Yes, I would expect that. That's why the industry is moving to knowledge-based methods in NLP. Absolutely. I mean, I heard the bad O word today in often in the interview with Matt as well. And ontologies were very much en vogue, let's say from 2002 to 8 or 9, and then nobody dared to touch it anymore because it's a hard problem in the end, right? Because in the end you create a many-to-many, like everything to everything relation, and then you don't gain much at all either. So if you don't structure this properly and make it searchable, apart from, as Jano said, apart from only text search, then it's not going to work out. And finding these knowledge graph-based approaches for combining like highly structured, standardized, formalized information with verbal descriptions is the big thing here, absolutely. Good. Anything else from the chat or on-site? I see lots of people nodding all the time, so let's is reassuring to some degree, but then again, you know.
I think Shaily had her hand raised before your discussion again. I don't know if the question has already been answered or if it's.
Shaily, is there another question you want to ask or discuss another aspect, or is that still the raised hand from before? Let us know.
That was an accident.
Okay. Yeah, it's like after 4 years of copy-based enforced training in webcoms, right? Good. So perhaps we can just do a very quick wrap up, except for anybody else wants to say something. Good. So let's perhaps take a quick look at what came up in different kinds of discussions all around the globe. So thanks for contributing, by the way, right?
There's one person.
Oh, there's another one. Robert, also St. Louis. Is that the same as we said before? No, from Shadow. Okay, seems like NEPQ and negative reverse spin selling has clouded the potential for NLP, don't you think? What is NEPQ again? Sorry for being ignorant here. Or Robert, do you want to come on stage quickly, because discussing this aspect, because NLP is a big one, obviously, like for a number of reasons.
Yes, so.
And it's very inherently spatial as well, by the way, no? Ivan, do you want to move Robert to the...
Already in progress.
In progress, perfect. Say what it means. Not so easily findable on the internet. Hi, Robert. How do you call you, Robert or Robert?
Robbie is what I go by, but Robert's my given name, sure.
Both of them sound very German, no?
All right. Well, here's kind of the question. I mean, I've been I'm an academic, but I've been in sales for most of my career, and a lot of the NLP can be flipped. There's what's called negative reverse spinning as a sales technique, and so all the NLP conclusions or transactional analysis that you can do with NLP essentially becomes well, it's not conclusive. So there's a way to go ahead and basically defeat any type of query that's done from a NLP transaction using what's now called NEPQ, as well as, you know, more generally negative reverse spin selling. And so I'm just, you know, I'm trying to point that out because I want things to move forward. I want there to be integrity in the data, and I don't want to go ahead and cater to the folks that are putting out misinformation and disinformation simply because there's a way to go ahead and cloud any real results. I mean, you know, zero is not all the is not the answer, and 0 divided by 0, meaning undefined, is definitely not the answer that we need to go ahead and move things forward intellectually.
Yeah, that's a very interesting one. I mean, we've been talking a lot today about human-generated or user-generated data, right? And of course, all these messiness, I'm going to get back to that tomorrow in the keynote as well, this messiness in social media data, but all others as well, but also metadata, right? I mean, like,
right,
correctly writing a description of a data set is just a challenge. No, it's not easy at all. So making sense of all that mess is obviously a big one. And the second thing, of course, yeah, how communication on the internet happens nowadays is extremely biased. I mean, before the bias question was on the emotions, and this goes both ways, no, with the emotions, but also the textual content, like semantics. We have a lot of excuses, by the way, why we don't do this kind of research. And so far, the excuses have been working somewhat well. I'm not so sure whether we can rely on them in the future, like for our particular case, at least. So can you, Robbie, can you quickly say again what the NEPQ thingy means and how it ties in with our...
Well, basically, NEPQ is a way to game any kind of NLP line of questioning. And negative reverse spin selling essentially will negate essentially anybody that's trying to follow any kind of logical reasoning train of thought. And so that's why I asked earlier if anyone had studied semiotics, because there's a way with semiotics of going ahead and coding a message to where it's sufficiently basic. There's a kind of a trilemma, if you will, of the sign, the signifier, and the signified. And I think that that's something that could be helpful. It's a very, very basic move, but I think by not framing everything as binary, but if we could go ahead and you know, use a third element. So again, sign, signifier, and signified would actually allow for human interaction to move forward and beat the, you know, the games that people are playing logically or mathematically with a lot of the coding that's out there. That's
interesting. And that's a great input as well. Like for our, let's say, semantic machine learning approaches, what we do at the moment is that we increasingly move towards active learning, like, I don't know, some kind of human in the loop approach, like which would really gives us an opportunity to basically try to get this like subjectivity in there and get different spins, get control of these spins as well. Okay, thanks again, Robbie, for joining us. So I'm quickly going to wrap up what we did like in the last like hour. Thanks a lot, by the way. We're going to condense this a little, and then we're going to send it out to the organizers, and we can always spread this. So thanks very much for contributing your data sets, goals, application areas, methods, and workflows. I think there's a lot to gain from. And just jumping back quickly, so these are the results that we're gonna share with you. I just wanted to say thank you very much again for contributing and for taking part here. In my opinion, as we've seen where the research world is going, we're going away from these, let's say, purely spatial approaches towards geographical analysis and integrating all different kinds of data sources, whether you want to call it like OSINT to different areas, whether we want to explain, I don't know, health issues and environmental health in different ways, or spreads of whatever spatial phenomena, from epidemiology to floods to refugee movements. All these kinds of things, I think, can benefit a lot from these multimodal approaches, because what we've seen is that we've been driving our machine learning models, like, I don't know, increase precision and recall by 0.03 percentage points, and then we're happy and write the next paper. But I think we're missing out on a lot that we can actually do when we integrate more data sources in a sensible way, and not sequentially, as also we did like for a while now, but simultaneously in integrated models. Call it information fusion, call it contextual enrichment, whatever it is. But then again, really merging, even if Simon was not so happy with this term, those modalities. Good. This is us again in the name of all organizers of the sessions. I can say thank you again for this very lovely exchange and sharing experiences. Good. So this is it from our side. Thank you.